Spheres. They're all around us, and we live on one. Sometimes spheres are our friends, and sometimes they're not our friends. There's an example of a sphere not being your friend. Hey, Darth Vader, do you like spheres?
Of course I do! The Death Star is a sphere!
Alright, so here we are in the Jarvis downstairs. And lo and behold, what do we have here? A table full of spheres. So if we look at this table, we've got, of course, the Wilson basketball, sphere. We have my arch nemesis, the soccer ball, sphere. We have some planets. I don't know which one this is. Also sphere. We have the blow-up beach ball, sphere. We have this little planet, must be Pluto. Is that even a planet anymore? I don't know. They've changed their minds. This looks like a Tupperware candy dish, also a sphere. That will come in handy later. But there's something common between all these spheres. They're all the same shape. And more importantly, what are they? The 3D circle. It's our version of the solid. And today we're going to be talking about how to find the total surface area and the volume of these spheres. Alright, so today we're going to look at a few of the formulas that have to do with spheres. And if we look at a sphere, everybody sees it and says, hey, it's like a 3D circle, if we want to think of it that way. You know, we're in this chapter on solids, we're talking about prisms, cylinders, pyramids, cones, and now we're into this 3D circle. And if we think about what kinds of things we can find, in this chapter we've dealt with finding lateral area, which is really the area of the sides. Does a sphere have sides? Not really. Things rolling all over the place. Does it have total surface area? Yes, it does. This sphere has total surface area, and the sphere also has volume. Now, one of the hard things that people tend to have when they look at spheres is drawing a sphere. So if we look at this, we can all start off and draw a circle. And now we sort of have to give this circle some depth. And to do that, a lot of times this is what they're going to do. They're going to draw like a little oval that way, and the dashed part of the oval in the back. Now, what kind of measurements or things go with a sphere? If we think of all the other things we've dealt with, where we've had area of the base, the height, there's really only one dimension that a sphere can have, and that is its radius. Yep, way to answer that question. So we look at this, it has a radius. We could also give the dimension of a sphere in terms of its diameter. But right now we're going to look at the two formulas that go with spheres. So the first one is total surface area, which again we're abbreviating TA. It's got a real easy formula to deal with that. And it is 4 pi r squared. So if we know the radius, all we're doing is plugging in for r and then evaluating. So let's look at our first problem. The first problem, we're going to let r equal 6. So the radius of the sphere is 6. So what are we going to do first? We're going to substitute in for r 6. So as we evaluate this to simplify this, we say, all right, what is 6 squared? And everybody knows 6 squared is, my assistant's
36.
36. So when we square 6, we get 36. So again, simplifying this gives us 4 pi times 36. Which of these are we going to multiply together? We're going to multiply 4 and 36 together. And everybody knows 4 times 36 is?
144.
Thank you, assistant. So we get 144 pi. So that's a total surface area. Alright, let's take a look now at volume. Now volume has the formula V equals 4/3 pi r cubed. And if you think of these formulas, it kind of makes sense that total area has r squared involved with it because area is measured in square units, and volume has r cubed associated with it because volume is measured in cubic units. So now we're going to use the example that we just used, a sphere with a radius of 6, and we're going to look at finding its volume. Now as I write this out, now that we're cubing something, we're trying to keep things easy, not get large numbers, so r cubed would be 6 times 6 times 6. Now we're just going to simplify some things out now. 3 goes into itself once, into 6 twice. And now we're just multiplying straight across. We got 4 times 2 is 8. 8 times 6 is 48. And then 48 times 6 is?
288 pi.
And then we have the pi with it. Thank you, assistant. We have 288 pi for the volume of a sphere that had a radius of 6. Now let's look at one more example. We're going to look at an example where the radius is 2 root 3. And we're going to find both the total area and the volume. So we're going to let the radius equal 2 root 3. And we're going to find total area and we're going to find volume. Now if we look at the total area, again, that formula was 4 pi r squared. What are we substituting in for the radius? Thanks, everybody said 2 root 3. So we got 4 times pi times 2 root 3 squared. Now when we square something like 2 root 3, just keep in mind you got to take that power and apply it to both things. So this is going to be 4 pi. 2 squared is 4. Root 3 squared is root 9, which is 3. So really, in a sense, you're canceling out that radical sign. So now I've got 4 times 4, which is 16, and then 16 times 3, which is 48. So we get 48, and then pi associated with that. We're keeping everything in terms of pi because we want exact answers. Now when we switch over to the volume, again, what was that formula? 4 thirds pi r cubed. Now what are we substituting in for the radius? 2 root 3 again. So this is going to be 4 thirds times pi. And we can write it this way. Can I write this as 2 root 3 times 2 root 3 times 2 root 3? And I think all that just fits in there. Now as we multiply this across, keep in mind, I'm multiplying all the outside terms together, and then I'm multiplying these radicals together. So I still have the 4 thirds, still have the pi. 2 times 2 would be 4, times another 2 is 8. Root 3 times root 3 is 3. And then bring down the last root 3. Can we cancel anything out here? Obviously we look here. 3 in the denominator, 3 up in the numerator. We multiply across now. 4 times 8, we're multiplying the terms outside of the radical sign to get 32 pi. And then we still have that root 3 tagged on at the end. So there's the volume. Now let's look at just one more example where, let's suppose they're giving us either the volume or the total surface area, and they want us to find the radius. So let's look at finding the radius. Shoot, I thought I did one of these. Let me flip back to my notes. Oh, here it is. Let's look at, suppose the total surface area is 64 pi. So if they say that total surface area is 64 pi, find the radius. Again, we're substituting into the formula. What's the formula for total surface area? TA equals 4 pi r squared. This is getting substituted in right there. So we've got 64 pi equals 4 pi r squared. What happens to these pi's? We divide both sides by pi's, they're going to cancel out. So if I've got 4r squared equals 64, now we need to get rid of the 4. How do we do that? Again, opposite operation, right? Dividing by 4. What's 64 divided by 4? So again, we go 4 goes into 6. 1 time, 2 left over, bring down to 4. 4 goes into, or with 2 left over. 4 goes into 24 6 times. So we're left with 16 equals r squared. How do we get rid of the square? We're taking the square root of both sides. Square root of r squared is r, and the square root of 16 is 4. So there's an example of where they may give you the total area, or they may give you the volume, and ask you to find the radius. Again, sphere is rather easy. There's just one dimension. So for homework, what I would like you guys to try, so to bring this to class tomorrow, we're going to look at finding the total area and the volume of a sphere that has a radius of 9, of a sphere that has a radius of 2, and of a sphere that has a radius of 3 root 2. And then I would like you to also find the radius. So here we're finding r if, we'll do the first one with the volume, if the volume equals 972 pi, And then the last one, find R if the total surface area was 600 pi. So I'll let you copy those down. Now the last thing I want to talk about is some special cases. So if I could have one of my assistants bring me one of those planets, one of the bigger ones. We need one larger than that. And if we look at this thing, again, this is a sphere, and what do we say we could do with it? Well, if I look at this sphere, and if I take it in half, we're actually creating something called a hemisphere. And if I look at a hemisphere, we could think about one thing. If I said, what's the volume of this hemisphere, what do you think the volume of the hemisphere is going to be in relationship to the volume of the whole sphere? And my assistant Marissa would say that the volume would be half of it. Sort of makes sense. Now the one twist we could throw into this is if I say, what about the total surface area of this sphere? Well, the total surface area would be half the surface area of the sphere, with one exception. What do we have to add into it? There would be a bottom to this, if we want to think of it as a base, which would be the area of
another half.
Well, not another half, but it's the area of a circle. So if they ask you to find the total surface area of a sphere, it's going to be half the total surface area of a hemisphere would be half the area of a sphere plus the area of the base, which is a circle. So try those 5 problems for tomorrow, and we'll move on from there. Thanks again.